I'm a solution architect with Amazon Web Services, and I'm joined today by Matthew Cates, who is the Country Manager Australia and New Zealand for Zerto. Today's introductory 101 level webinar is going to be on using AWS for disaster recovery. Today we will be covering a number of concepts around disaster recovery for primarily on-premises systems using AWS as a disaster recovery mechanism or disaster recovery location. Matthew will be speaking later on Zerto's part in that overall architecture and how to use Zerto to enable AWS as a disaster recovery location. We'll talk a little bit about some of the basics around AWS, around DR, some of the concepts. We'll touch briefly on some of the AWS services that we're going to use, and we'll step through different levels of disaster recovery. Amazon Web Services publishes a white paper called Disaster Recovery on AWS that talks through, as we'll see shortly, 4 different standardized disaster recovery scenarios and mechanisms, and provides blueprints and best practices for each of those mechanisms. So we'll show you what those are and then how they can apply to your systems. Matthew will then step in and discuss Zerto, and then we'll have a summary. If you have any questions, please post them in the questions and answer section. One of the team will answer the questions there for you. A recording of the session should be made available after the session. So within the next few days you should get an email with a link to be able to download this and then share it with any of your colleagues who may have missed the session. We'll also be following this up in a couple of weeks with the Lunch and Learn events. That'll be happening across Australia. That's a 200 level in-person set of events. Most of you should have received emails with invitations to those events. If you haven't, please let us know. And that covers a similar set of concepts, but at a deeper, more technical level and goes into a lot more depth. So to start with, we'll cover off some terminology. The first one here is business continuity. And when we're talking about business continuity, this is really not so much of a technology discussion at all. Business continuity is about business functions being able to continue to operate or recover after a serious incident. So if we think about a serious incident, we may have actually no technology affected at all. It could be something like, for example, a building catching on fire. Everyone gets out of the building, but no one's able to get back in and find records, paper records, for example, something like that. So at a functional level, how does the business continue to work after an event like that? For the course of today, we'll be using business continuity in a more technology-centric sense, but we still have to think about how these things function in terms of business processes. So if we take that example of your office or a building catching fire or being torn down or something like that, then you may have laptops, desktops, things like that that might be left behind in the building, obviously, and are unable to be used afterwards. How do your staff go about continuing to do what they need to do? And as a team of technologists, what do we need to be able to do to ensure that those businesses can continue to function? Do we mean providing spare laptops for people? Do we use, for example, use virtual desktops and allow people to work from home? In New Zealand, the Christchurch earthquake in 2011 prompted an awful lot of businesses to come up with some really innovative solutions about how they continue to allow their staff to work despite the fact that they didn't have an office anymore. Disaster recovery, on the other hand, for us, is really more about the technology infrastructure and systems recovery. So when we've lost a building, or when we've lost a location or something like that, or perhaps we've just lost a whole load of IT infrastructure, someone's pushed a rack of equipment over, for example, and destroyed things. At a technology level, how do we go about recovering from that and then continuing to operate? And that disaster recovery feeds down to 2 critical concepts when we're talking about this stuff. The first is a recovery point objective. A recovery point objective is really simple. It's how much data can I afford to lose? Now, typically when I start a disaster recovery discussion with someone and I ask how much data they can afford to lose, the starting point is 0. We can never afford to lose any data. And I don't think we've got a graph here in the slides, but if you think about it in terms of a graph, the lower your recovery point objective, the less data you can afford to lose. The more expensive, the more technologically complex an overall solution is going to be as a generalization. And so if we think back a long time ago, people would run a backup of their systems, and they'd run a backup once a day. And so if a system failed just before the next backup, your recovery point objective there is 24 hours. We could lose up to a day of data. And so part of what we're jointly trying to do here with Amazon Web Services and Zerto is provide cost-effective and simple ways to reduce that recovery point so that your maximum amount of data that you might lose is as close to zero as possible. And then there's the recovery time objective, and that's how long is it going to take things to get back into service after we've had an issue. Now, I'm working with a customer currently, and we know that they can go through a manual set of processes and recover some of their database servers in well under 4 hours. That's their recovery time objective. If a system fails, they're happy they can recover it in 4 hours. This is a company that's growing quite fast, and what they're trying to work out is we can recover a failed database server in 4 hours, and it's going to involve some manual effort. But what if we lost all of our database servers? What if we had a software bug introduced? And now we've got to start thinking about this stuff in terms of volume, not just in terms of handcrafting things. And as you'll see later on, we'll start talking about how we automate some of the stuff so that recovery time objective becomes as low as possible because we minimize the amount of human intervention that's needed. So if we look at this on a graph, it's pretty simple. We have a graph over time here running from left to right. The RPO, that's the point when we last, say, took a backup or shipped a copy of data somewhere else. We have a disaster at some point later, and we've lost all of the transactions, all of the data that's happened since that last backup, that last recovery point. And then continuing on from the disaster until we return to operations, to use another acronym for the same RTO, recovery time objective, or return to operations. That's the point when we're back up and running. And so that's the downtime between the disaster and the RTO. And really what we're aiming for here is to try and make both of those numbers, both of those sizes, as small as possible. We've got to think about things in terms of different types of disaster as well. So floods, natural disasters, for example, fires, etc. And these are kind of big, wide area disasters that affect, whole cities, whole states, a large number of buildings, for example, in the case of a fire. But then we also have a different set of disasters underneath. We might have a hardware failure, for example. We might have a catastrophic hardware failure. We might have a bug that's introduced in a particular piece of firmware in a set of disk drives, for example, wipes out a whole load of systems at the same time. We might also have things like malicious attacks, so people-based attacks, whether that's internal or external, having people come in and attack your systems from the outside, disgruntled employees, or perhaps just employees who don't realize the nature of what they're doing. It's really easy to get confused, perhaps if you're working on test and development and you go and do something, you find out you were actually working in a live environment, not test and development, you've made some changes, and now reverting those changes could become really, really difficult. So not just malicious users, but also just accidental deletion of files, for example. So as a set of IT practitioners, we've had concepts of disaster recovery for a long time. I've worked in the disaster recovery field for about 15 years or so myself, and I've seen this evolve over time. And when I first started working on this stuff, I had a lot of customers who would build another data center or build another server room down the road. And so now they've had to go through an awful lot of time and expense. They've set up another disaster recovery data center. They've had to go through all the networking connectivity that's required to get that set up and private connectivity. And because you're dealing with a risk versus reward system here, trying to find money to essentially buy and spend a lot of money up front in a CapEx model on what is effectively an insurance policy becomes a really difficult thing to do. So we get customers who buy a new set of hardware, and then the old set of hardware gets moved into the disaster recovery data center. And so now we don't have an environment in DR that looks like our environment in production. So that makes things like failing over and testing it become really, really difficult. It's extremely rare, sort of going back a way, that I work with customers who would regularly test the disaster recovery because it was quite a fragile solution. And also moving from primary production environment into a disaster recovery environment was something that wasn't easily undone. It wasn't easily able to be tested because we couldn't segregate out networks and things like that. And so as technology's advanced, a lot of these things have become a lot easier. Right? People build up a lot of advanced manual processes, there's a lot of technical debt going on, and technical debt is where you create a solution and you know it's not going to work or it's not optimal, but you don't have time to fix it. And so things there get out of date, they get languished behind, perhaps you have a set of servers in your production environment that are on this version. You haven't gone and patched the version in disaster recovery environments because you're not using your disaster recovery environments, so it doesn't matter. And now you've got things that are out of step. You've got technical debt that you've got to go and pay down later through work. And so we're trying to make this stuff minimize as many of these kind of challenges as possible. So why AWS? How does AWS do this? There's a number of different approaches that we take and that we partner with companies like Zerto to enable you to do this stuff more simply and easily. The start is that Amazon Web Services is a pay-as-you-go mentality. So you can build the framework and the templates for disaster recovery environments on AWS, and you're not having to buy all of your capacity up front. So there's no upfront building of disaster recovery sites or data centers. It's a very low upfront investment. We'll see in a minute some of the disaster recovery models that we produce that talk about different balances of return to operations and recovery point objective versus cost. There's no ongoing OPEX costs as well. So if you're running a minimal amount of machines just to keep things ticking along in disaster recovery, your AWS bill every month is going to be very, very small. And then as and when you ever need to push the big red disaster button, move into DR, that's when you'll start paying for the capacity and the processing time and things like that you're using in AWS when you're using it. We offer a consistent experience across AWS environments as well. So you can standardize environments, different applications of yours that require disaster recovery can be templated in a standard manner in AWS, and that leads to the next point of recovery automation. Now, we can do things in AWS like creating entire new network environments, standardizing those, and so you can stand up a disaster recovery environment in an isolated bubble, test that, make sure that it does what you want, and then shut it down and stop paying for it without having to go through a whole lot of extra capacity planning and things like that, right? And this enables you to do things like separate disaster recovery per application or per business unit. Going through, very commonly we go through an application assessment or an application profiling exercise when you're thinking about this kind of thing, and working out which systems are actually important, which systems need to be protected with DR, and which systems do we not need to protect with DR. Looking at this from the point of view of a DR topology map and mapping things that are probably familiar to you into things that AWS does, right at the top, you have things like the domain name system. If you're running things like a public website or mobile applications or anything like that, or even internal systems that have got to know where other applications are, your clients need to know where things are, you'll use DNS to do that. Amazon has a DNS service, it's called Route 53. It's compatible with all other DNS services. It's a very standard thing. It can be quite smart. Again, it can be automated. So you can not have things in AWS until you need them, and then when they are up and running in AWS, Route 53 can show you where they are. If you have things like load balancers in your data centers, then we have the Elastic Load Balancing service in AWS, or you can go and get a third-party appliance. So if you're using some of our technology partners, F5 or Citrix, for example, to do your load balancing, you can come and get an F5 or a Citrix soft appliance in AWS on a pay-per-hour basis through our marketplace. Your web servers, your app servers, your database servers are all going to be what we call EC2, Elastic Compute Cloud, so virtual machines on demand in AWS. The database servers will be potentially running the whole time, potentially not, and used as failover targets. We integrate with things like your existing Active Directory, so you can put Active Directory or your authentication servers on your own premises. You can have copies of those sitting up in AWS as well if you need to. You're probably thinking in terms of data centers, or server custody, server closets, server rooms, things like that in your own environments. And the analogy for that with AWS is an availability zone. An availability zone in AWS is a collection potentially of data centers, and in each AWS region we have multiple availability zones. So in the Sydney region, for example, we have 3 availability zones. Each of those is a separate set of data centers, separate networks, separate floodplains, power grids, things like that. So if we have an issue in one availability zone, one set of data centers, then that's isolated away from the other availability zones. So you can think of an availability zone as a data center. Logically, they look like the same thing. And then for customers that require really, really wide area protection. You can use multiple AWS regions. So a region is a city or a state or a country. So we have a region in Sydney. We have another region in, say, Singapore. We have another in Japan. Just launched one in Mumbai in India. We have another one in Oregon, California. So you could replicate things and have a primary disaster recovery region in Sydney, but also replicate data to one of those other regions geographically very distant if you needed to. When we talk about ascending levels of disaster recovery options, these are 4 standard patterns that AWS introduces. The first is backup and restore. So continue doing what you're doing right now, continue using your backup systems, and then copy the backup data into AWS so that you can restore it into AWS in the event of a disaster. Typical RPO, so recovery point objective for that, I might back up once a day. I could stand to lose 24 hours of data, and it might take me a day to recover that because I might have some manual processes and things. Low cost, very low effort, very easy to set up. A step up from that is a pilot-like disaster recovery architecture. So if you think about the previous levels diagram, the layer cake, we might have some systems like your Active Directory services or your authentication services, your database servers, running in AWS on very small systems, able to handle continuous replication of data into AWS or batched replication of data into AWS, but very, very low cost, very small systems. And when you need to invoke disaster recovery, then you have some automation tools that enable you to stand up the rest of your environment, and much like a gas appliance, the pilot light allows you to kick everything else into gear. Then we have from there a warm standby. A warm standby is running systems or having systems that are full size, that are ready to go, maybe instances, EC2 instances, virtual machines that are there but that are shut down and not running yet. So rather than having to create new systems or anything like that, we can simply switch things on or make things slightly bigger. But you are running essentially a complete copy of your production systems in AWS, but at a smaller scale. Now, this is a little more complex because you do now have another set of systems that you've got to run and that you have to manage, patch, maintain, things like that. But it does offer a much smaller return to operations. We can bring this up very, very quickly and a much smaller recovery point objective. And then lastly, this idea of a multi-site environment. So running essentially a full-size production-ready copy of your application systems in AWS, and that means that you're able to switch over between your existing on-premises systems and AWS at the touch of a button. No warm-up, no resizing needed, everything is ready to go. That obviously is going to be the highest cost because you are going to pay for things, and you might decide, for example, let's say if I work for a retail organization, most of the time I might decide to have a pilot light system because most of the time people aren't visiting my website in a huge level of like huge torrents. But when I decide I'm going to have a sale and I know I've got a large number of visitors coming into my site, I could shift from a pilot light to a multi-site kind of environment fairly easily. And then when the sale's over and I don't need that immense level of protection, I could go back down to a pilot light architecture and stop paying for things. So I'm not going to dive into this in a lot of detail, but here are collections of the different AWS services that we use depending on which one of these 4 approaches you want to take. Bear in mind here you can mix and match these approaches on different applications. So some applications might warrant a multi-site setup, others might only warrant backup and restore and so on, and you have the freedom to choose. The point here is that we have these 4 broad groupings of systems: networking systems, storage systems, compute, and then deployment and management systems. So things like the green box at the top here is a service called CloudFormation. CloudFormation is a templating service that allows you to deploy systems automatically when you need to. That means you can run a pilot light environment and then deploy a CloudFormation template to spin up the rest of the environment. So we do have all of these systems and all of these architectures covered in a white paper in a lot of detail. This is the kind of thing that the white paper dives into. An architectural diagram like this that shows you pictorial representations of what things could look like, your backup systems, etc., and then how you get that data into AWS and the kind of AWS services that we use here. We also then go through cost estimates in the white paper that give you an idea of how much this is going to cost you. So something like this, an architecture which is predominantly backup and restore, might be as little as $200 a month if you're storing several terabytes of data. Right? Again, with AWS, you get in there, you pay for what you use. Right? Backup and restore details, obviously, as we said a few slides ago, very suitable for low criticality of applications, things that have a very relatively high recovery point objective, a relatively high recovery time objective, things where you can afford for them to be down for a while. The pilot light architecture. So here we have, as you can see at the bottom, a database server that's running all the time in AWS. You're replicating data, and then as we need to, we can bring up other systems using some templating systems. We have here, a cost estimate for this. For a similar kind of system, we might be looking at $300, so 50% price increase over the backup and recovery, but a much lower time to recovery. We're going to talk a lot more about how Zerto can help you with this kind of thing, for example, and I'm going to hand over to Matt shortly to do that. The warm standby architecture is very similar, but takes us a step further, where we're running these things at the top right-hand side of the diagram here all the time, ready to go, but are not necessarily running them full size or full scale, and then we can simply change the sizes later. Again, we go through pricing here, and you can see the pricing increases and the costs per element inside there. And then the multi-site architecture is largely the same, but here we're using Route 53 at the top, the DNS service, to balance across both of these systems, and that gives you an idea of how much that's going to cost. Right? So the warm standby and multi-site kind of systems are great for those things that require recovery time and recovery objective in the minutes, the core business functions, the things that are going to be really, really critical for you, and that obviously does come at a slightly higher cost. So I guess the key lessons learned here are that while you can do a lot of the stuff with AWS, integrating third-party solutions, particularly the likes of Zerto, into these, takes that to the next level and simplifies what you're able to do. And going and talking to our technology partners like Zerto who offer solutions, and then our joint consulting partners, these are the partners that can help you as customers get things set up, ready, and run. Right? Use this as an opportunity to automate processes and get rid of that technical debt, and then go and talk to other customers and see how they've done with things as well. With that, I'm going to hand over to Matthew to talk about how Zerto helped with this further on. If you have any questions, please do ask them in the questions and answer window.
Thank you, Richard. Let me introduce myself. My name is Matt Cates. I'm the country manager for Zerto in the Australia and New Zealand region. I've been lucky enough to be the first employee that Zerto hired in our APJ region 2.5 years ago, and what was a small operation with about 20 end users has grown to a team of over 30 people across APJ, a customer base of nearly 200, a large partner base in ANZ of over 50 certified Zerto resellers and cloud enablers. Really excited to be here partnering with AWS and talking about a very relevant and very exciting set of topics here. So Zerto as an organization globally for the last 6 years has been delivering on our core competency, which is providing exceptional outcomes across multiple different types of platforms for disaster recovery. We want to provide enterprise-class replication and recovery solutions on VMware environments, on Hyper-V environments, and certainly allow organizations to take their environments, move towards a hybrid cloud model, and utilize AWS for disaster recovery. We're going to frame a problem today. DR, disaster recovery for many enterprise organizations in the past, has been a complex, very expensive, and counterintuitively risky operation. It's hard to test, sometimes impossible to test. Managing like-for-like assets across multiple physical sites is very challenging, it's very complex, and is often very expensive. What we want to talk about today is using Zerto in conjunction with AWS's revolutionary cloud service model to deliver automated, secure, and very cost-effective solutions. So today's discussion is how do we move from a static, complex, very capital-intensive DR infrastructure model towards a very flexible, elastic, automated, next-generation platform. And so the best way to actually demonstrate this, rather than going through 50 technical slides, is to actually look at what the experience of invoking disaster recovery, executing a failover would be with Zerto and AWS. Let's see what this thing would look like. Is it complex, or, as I will argue, has Zerto made this very, very simple. Given any type of disaster event, Richard talks about both geographical events, physical failures, even logical corruptions. There's a long list of things that can go wrong in today's very complex IT environment, and given an interruption in service, Zerto provides a very simple automated process to invoke DR and get back up and running quickly. So let's look at that. Given an event has occurred, Zerto's interface will quickly and very elegantly make that clear. Services have been interrupted and action is necessary. With Zerto's infrastructure, just click the failover button, big red button at the bottom right hand of the screen. The next workflow step here will just be a simple process of selecting one or multiple or all applications that you'd like to recover in your chosen DR location. Select those apps, select which point in time you'd like to roll back to, given some kind of physical failure or actual geographic disaster, a storm, a flood, an earthquake. Just choose the latest checkpoint. Let's get back up and running, giving us the minimal amount of data loss, in many cases just a few seconds. Given some type of logical corruption, perhaps some type of human error event, or certainly, as Richard talked about, a malicious intrusion type of corruption, crypto locker, for instance, perhaps we want to go back a little bit further. Perhaps we want to roll back to several minutes ago, an hour ago, whenever that corruption had not occurred yet. We can allow you to roll back to seconds before that event. Given those choices, the next step is actually executing the failover. It's really that simple. Zerto will automate the process of winding down your production infrastructure that's been compromised, of executing the failover and all the steps necessary to do that, and spinning up those workloads in your DR or target site. So, reflecting on that, what we've got here is a very revolutionary architecture. We know that building, maintaining, and evolving on-premise infrastructure, owning capital assets, setting up and integrating that is very complex. We certainly are excited by the revolutionary services that AWS offers. AWS has done an immense amount of building and integrating work to deliver exceptional services. All you need is your credit card. Well, with our disaster recovery services, with Zerto and AWS, we're providing almost limitless capacity, an on-demand nature of consumption, and a very simple, scalable, secure model for disaster recovery. Let's talk quickly about Zerto's lineage. Our founders have been building and selling replication technologies in the enterprise for disaster recovery purposes for the last 18 years. Zerto as a company has been selling our product, an award-winning replication platform, replication and automation platform, for the last 6 years. The lineage of the company was that we thought that replication was happening in the wrong place. Functionality tied to physical assets is limited by vendor lock-in and struggles to take advantage of next-generation services like Amazon Web Service. Well, Zerto is the first hypervisor-based replication platform. It's definitely the first enterprise-class software-defined solution that allows you to replicate and automate to a multitude of endpoints. Is anyone using this platform today? Absolutely. As I mentioned, in the ANZ region, I've been lucky enough to see our customer base grow from about 22 when I joined to almost 200. That spans end users, spans partners, and those organizations, of course, are not just small, but sometimes very large regional and even global organizations. Richard touched on this. Of course, in the Australia and New Zealand region, natural disasters are a fact of life that have to be planned for, but there's other sources of service interruption, whether it's power failures, normal, expected, but certainly compromising hardware failures, network outages, and then things like human error, and certainly, perhaps very relevant in today's world, security compromises, malicious intrusions. An organization needs to be prepared not just for some, but for all of these. And Zerto and AWS deliver a set of functional outcomes that protect against all of these different types of outages. Looking at the way that disaster recovery has traditionally been done, Richard certainly touched on this, most organizations are familiar with the backup process. But certainly a multi-hour or perhaps multi-day gap in protection provides significant risk to the business given an outage. In today's 24/7 always-on IT environment, losing 24 hours worth of data is simply too compromising for a business. Certainly some organizations have turned to taking snapshots, perhaps VM level or storage level snapshots. I would certainly not argue that that's an improvement over a 24-hour data loss gap, but it's still perhaps risking multiple hours of data loss. It's a performance inhibiting action. Taking a snapshot is going to tax your production systems and thus introduce a trade-off. Do I want to reduce risk but also sacrifice production performance, delivering my services to our business and our clients, or do I sacrifice protection and thus have less impact on my system? That's not a trade-off that organizations should accept. When they have to deal with things like CryptoLocker, with human error, with power failures, hardware failures, these trade-offs, these sacrifices in risk reduction can impact the business significantly, often leading to significant and debilitating data loss and downtime. So Zerto's in the business of minimizing impacts, minimizing risk. Because we're a continuous data replication technology, for 14 days you can protect and store every data change that occurs in the environment. If some type of compromising event occurs, Zerto can allow you to roll back to seconds before that event occurred, minimizing the impact in your environment. Through our automation platform, will allow you to quickly, easily, and securely get back up and running in a matter of minutes. Zerto allows you to protect entire sites, certainly application by application, individual virtual machines, and now even restore files. If we're summarizing Zerto's platform, we're a simple, scalable software platform. All you need to do is download a software license, apply it to a virtual machine, and you're ready to go. Our always-on continuous data replication is second to none in the industry. We protect against hardware failures, corruptions, ongoing. We capture every data change. The platform gives you a very high level of visibility, of assurance, the ability to test DR, the ability to report on the health of your environment, which is critical for an enterprise and any organization that has any type of auditory requirements. This is a critical point. We're technology agnostic. That's why we're here with AWS today. You can use Zerto to replicate from on-premise physical sites, VMware, Microsoft Hyper-V, hypervisor platforms, and use AWS's elastic and very cost-effective platform for DR. When we compare running a disaster recovery site that you own, that you operate, an immense amount of considerations and dependencies, to Amazon's OpEx, flexible, scalable model, we can definitely start to understand the simplicity that's introduced. We've been talking a lot about the technical advantages to implementing Zerto and AWS disaster recovery services, but there's certainly financial benefits. I really encourage everyone on the call today, anyone who've used this webinar in the future, to go to AWS's ROI calculator tool and start to dig into how much money you may be able to save if you start to eliminate physical owned assets in a DR site and move those services to AWS. As an example, when replicating data to AWS for DR, that data is written to Amazon S3. There's no need to run EC2 instances until you want to test DR or DR is invoked. It's a huge cost savings and can start to inform the savings that you see in this example chart below. So let's look at the architecture very quickly. Zerto has two main components, our virtual manager and a thin provision software appliance that sits on any physical host in your virtual environment. As mentioned, we're continuously replicating. We're delivering a recovery point objective, very often in seconds, and certainly a lot of our clients experience single-digit second recovery point objectives. We're not taking snapshots. There's no performance impact to your production environment while delivering this exceptional service level. When replicating to AWS, Zerto's cloud appliance will manage that process in an ongoing manner. We'll replicate to S3, a very cost-effective elastic storage repository, and as mentioned, only when testing or only when DR is invoked would you start to consume EC2 resources, making this operation very cost-effective. A critical point for organizations who are considering DR into the cloud is the platform that delivers the replication and automation. Certainly, we think that Zerto is the best platform to do that, and I want to take a look at a reason why. Enterprise applications are made up of multiple virtual machines, multiple different types of services that, architected together, deliver that enterprise application and that service. Given the interdependencies, replication occurring for an enterprise application that lacks any type of consistency grouping is going to deliver a very risky and unscalable result. You can't have virtual machines being restored at a target site that are not protected with right order fidelity, that are not maintained across those VMs in a consistency grouping. It's risky and it's unscalable. What's very exciting to learn today is Zerto is the only platform working with Amazon to deliver disaster recovery services that has the concept of that consistency group, of a virtual protection group. Zerto allows you to encapsulate a group of VMs that represent an application into what we call a virtual protection group, assigning consistent policies that stay with that group of VMs, with that application, as it's continuously protected as it is failed over or moves into Amazon. The result, a simple, scalable, and very secure protection group, not just of individual VMs, but multiple VMs representing an application. We're replicating with right order fidelity, which means Zerto is protecting and writing each data change that occurs across all of those VMs within an application in order. We're taking care of things like preceding, boot order, even IP reconfig during a failover. And of course, as you're using virtualization services at your production site, you don't want to sacrifice functionality like vMotion, like storage vMotion, to maintain a consistent level of DR. Well, because Zerto is fully virtual aware, we can absorb any changes to your virtual environment without breaking DR. Another critical component of the consistency group. When executing failover to Amazon, Zerto automates the entire process, delivering a very impressive recovery time objective of minutes or a few hours, depending on the size of the environment. We're going to automate things like the boot order of each virtual machine within a consistency group, re-IPing, even scripting and validation services can be introduced into the environment. A critical component of any DR strategy, and possibly one of the most exciting features within Zerto, is our ability to deliver non-disruptive live failover testing. Let's dig into that a little bit. A lot of organizations that we work with struggle to execute a DR test. Even if they're able to, it takes weeks to prepare, application dependency, downtime planning, often takes weeks, and certainly people are coming in the weekend to execute that DR test outside of normal business hours. With Zerto, we deliver non-disruptive live failover testing. You can do a DR test on a Thursday morning while production is running. Your production systems will see no interruption, and equally as important, there'll be no interruption in the protection schemes that you've got engaged. Zerto will continue to protect, continue to replicate. Thus, if any type of event were to occur during a DR test, there's no gap in protection. You simply tear down that test and execute a live failover. It's very similar to a failover operation is our ability to actually permanently migrate workloads in an automated manner to Amazon. And finally, if DR is invoked, Zerto allows you to make use of VM converter tools and fail back to your original production site when that disaster event has been mitigated. As mentioned, Zerto's dashboard is going to give you a real-time global view of your environment across multiple VMware, Hyper-V, and AWS environments, giving you a true single pane of glass for all DR functions. The ability, as we mentioned, to do live non-disruptive testing is very powerful. We have a rich set of reporting and compliance documents that can be printed, delivered to the business on an application-by-application basis, summarizing and detailing a DR test or an actual failover or migration so that the business can understand what occurred and whether or not it was successful. To summarize, Zerto is an incredible virtual-aware multi-tenant DR platform. It installs in minutes, it's software only and licensed per VM, and it delivers enterprise-class, best-in-class service levels. There's no snapshots. We're continuously protecting with no production performance impact. The efficiencies that Zerto delivers in conjunction with AWS for DR services are found both on the technical level and in terms of the cost efficiency of the solution. There's no impact to testing. There's no impact to migration. And the functions you've seen today work whether your environment has 10, 15, 20 virtual machines, whether those VMs are very small, or whether your environment has thousands of VMs, large and small. Zerto's services in conjunction with AWS work irregardless. And let's finish with an important point. The efficiencies, both in the technical and commercial level, are unmatched when Zerto is paired with AWS disaster recovery resources. On behalf of Zerto, I'd like to thank AWS and anyone who's attended. I really appreciate your time and attention, and I do hope to speak to some of you in the future to further answer questions.
Good stuff. Thanks very much for listening, everyone. Just wrapping this up, in summary, there's a set of really good reasons to use AWS for your disaster recovery for your on-premises systems. We've walked through a little bit about why AWS and the advantages of that versus a traditional disaster recovery architecture. Walked through some of the different levels of disaster recovery and reference again to the AWS disaster recovery white paper that speaks to those in a lot more detail. Talked a little bit about those scenarios, and then you've heard from Zerto on how they partner with AWS to make this stuff really quick, really easy, and something that systems than you might have thought. We'll be following up with a lunch and learn across Australia in the next couple of weeks. As we said at the start, if you haven't got an invitation for that already, please do let us know via the chat window. Thanks very much for attending. If you've got any other questions, please ask them now via the questions window. Thanks a lot for your time.